Hello friends. The subject is power electronics. This one important subject for any competitive point of view. Take either GATE or IES or any PSUs. Okay. Before going to according to syllabus for various competitive point of view, first go through with what is the weightage from the power electronic subjects in various competitive point of view. Finally, for GATE point of view, from the power electronic subject, the expected weightage is, can expect 8 to 10 marks. In an average, I am telling. You see the weightage from 1991 to up to 2018. By taking average, I am telling, you can expect 8 to 10 marks. In some years, in one or two papers, it is asked 12 marks also. Maximum 12 marks is also asked in power electronics. But average, I am telling, we can expect 8 to 10 marks. Okay, for GATE point of view. For IES point of view, the expected weightage is for both objective and descriptive. For objective point of view, here I am giving questions for objective. The expected questions is 12 to 15 questions. For descriptive, here I am giving marks. We can expect 20 to 25 marks. Average I am giving. This is expected weightage in GATE and IES. Any other PSUs, you take any other state government jobs or central government jobs, for any other PSUs, in the total marks, we can expect 8 to 10% of total marks. Okay. This is the expected weightage in various competitive point of view from the power electronic subject. Okay. Yes. Then what are the reference books for this power electronics? What are the reference books you follow? Reference. One is Power Electronics by P.S. Bimra. This one important book for any competitive point of view. This is available in, it is in Khanna Publications. The another important book is Power Electronics by, actually the title is available, Power Electronic Devices, Circuits and Applications by. Simply I am giving like this, Power Electronics by M.H. Rashid. This available in Pearson Publications. And power electronics by MDC, power electronics by MDC, and power electronics by Cyril W. Lander. This is available in McGraw-Hill publications. McGraw-Hill publications. But mainly concentrate on one important book is P.S. Bimra. Then you give the preference power electronics by M.H. Rashid, MDC. But this power electronics by Cyril Lander mainly concentrate on this numericals. Problems, it is very important book. For problems, this important book. And these three books, you refer both theory and problems. This you refer both theory and problems. Both theory and problems. This book is important. These three books. Okay. This is weightage in various competitive point of view, and these are the reference books. Now come to the what are the topics I want to discuss in this subject, in power electronics subject. What are the topics I want to discuss? I will start with some introduction. These are the topics I want to discuss. Okay. This is weightage and these are the reference books. And come to the topics. Here I am dividing into different chapters. The overall power electronic course is discussed in the following chapters only. Okay. What are the topics I want to discuss means mainly concentrate. First I will start with some introduction. I will start with some introduction. Then I will cover with chapter 1 is first chapter, that is chapter 1 is types of switches. I will cover with the types of switches. This is chapter 1. Then chapter 2 is start with the power semiconductor devices. Then under chapter 2 mainly what are the different types of power semiconductor devices I want to discuss here. First I will start with that is power diode concept. Then I will start the concept of thyristor or SCR. With respect to thyristor and SCR, so many subtopics also there that we will see in the discussion of about thyristor or SCR. Then third concept in the chapter 2 is, then after discussing thyristor and SCR, I will discuss GTO concept, gate turn off thyristor. Then I will go through with the diac and triac concept. All these power semiconductor devices, diac and triac concept. Then fifth concept is, we will start with different members of thyristor family, different other members of thyristor family, or we concentrate on different devices of thyristor family, different devices of thyristor family. thyristor family that I will discuss. Even GTO and triac is also one of the thyristor family, but along with GTO and triac, there is other members of thyristor families also there. Those devices also I want to discuss. Then after this, we'll start with BJT, MOSFET, IGBT. Then in this second chapter, I want to discuss other members of transistor family. Other members of other devices, you take it. Other devices of thyristor family. Sorry, transistor family. Other devices of transistor family. All these concepts comes under chapter 2. Then in chapter 3, I will start with the power electronic circuits. Start with power electronic circuits. In this power electronic circuits, in chapter 3, in this I will start with some introduction, that is introduction to the power electronic circuits. Then again I go through with the rectifiers, then inverters, then choppers. All these comes under chapter 3 only. Choppers. Then AC voltage controllers or AC voltage regulators. Then cycloconverters. Okay, cycloconverters. This comes under chapter 3. I want to discuss all these concepts. Okay. Power electronic circuits. After discussing some introduction, then I go through with the rectifiers, inverters, choppers, AC voltage controllers or AC voltage regulators, and cycloconverters. Okay. Is it completed? Are you note down this one? Okay. Then go through this. All are note down. Then I will start with then after completing this third chapter, then I go through with fourth chapter. Fourth one. Then in fourth chapter, I want to explain fundamentals of drives. Okay. Then finally, this is fifth chapter. This is fourth one. Then finally in the fifth chapter, I want to discuss, or I want to give some practical examples on power electronic circuits or examples on practical applications. Examples on practical applications. I want to give so many examples. The practical application of this total course. Actually, the power electronic course will be completed up to fundamentals of drives. Then after studying all this, up to this important for any competitive point of view. But you want to understand the subject in the application point of view means, then I want to give some examples on practical application. Then you clearly understand where we are using this subject, where we are using this technology. Okay. Then these are the topics I want to discuss in total power electronics subject. But in some competitive, actually total power electronic course is up to fundamentals of drives. The total power electronic course up to fundamentals of drives, the total power electronic course will be completed. But in various competitive point of view, the syllabus is mentioned. For example, you take GATE point of view. In GATE point of view, the topics are given up to inverters and choppers only. But in the previous GATE syllabus, they given up to drives also. But now, according to GATE syllabuses, the syllabus is mentioned up to inverters and choppers. Okay. But in IS point of view, the syllabus is mentioning fundamentals of drives. But whatever may be the competitive exam, it may be IS or GATE or any PSUs, you want to know the total power electronic subject. Once you want to know the total power electronic subject means, then I want to cover all these chapters. Okay, chapter 1, chapter 2, chapter 3, chapter 4 and chapter 5. Okay. And this fifth chapter is not for competitive point of view. Okay, they don't ask explain any practical example of like that in power like that they don't ask. Okay, but this fifth chapter is, once you are studying this total subject, you want to understand what the practical example, what the practical application of this subject. That's why I am giving this fifth chapter only, examples on practical applications. Mainly our concentration is for any competitive point of view up to fundamentals of drives. Yes, understood? Okay, then we go for the practical application only for understanding the subject only. Then you note down all these. Then I will start with some introduction. Later on we go for according to different chapters. Okay, first we will start with some introduction. Okay. Okay. I want to explain, I want to give some introduction to this power electronics subject. Can you tell me what is the power electronics? What is power electronics? Can you think? What is power electronics? Okay, see, once I am teaching this subject means, once we are studying this course means, first you know the what is the importance of this subject. Okay, that's why I am giving some introduction only. This introduction I am giving because to know the what is the importance of this subject. Then for any competitive point of view, go for according to chapters only. Okay. Yes. Here just for understand, this is not exact definition. After 1 or 2 minutes, I will give what is the exact definition of power electronics. Just for understanding this definition, first I am giving. We know that we are all EEE students. EEE. That is electrical and electronics engineering. Electrical and electronics engineering is divided into 3 parts of specialization. One is power engineering. Another one is control engineering, electronics engineering. This is the three parts for specialization. This is only for just understand. Then what the power electronics means? Use of electronic devices to control the power. Use of electronic devices to control the power is nothing but a power electronics. Use of electronic devices to control the power is nothing but a power electronics. That means this power electronic subject explains how the electronic devices are used at power level, how the electronic devices are implemented at power level, how the electronic devices are used to control the power and to convert the power. All these concepts are explained by power electronic technology. Okay. This is one of the simple definition of power electronics. Use of electronic devices to control the power is nothing but a power electronics. But it is not exact definition. What is the exact definition of power electronics? Later on I will give. But point to remember, among all the technologies, the more popular technology is power electronic technology. Nowadays and in future also, which is the more popular technology? Is the power electronics is the more popular technology. Why I am telling like this means, I will give one or two examples also. This power electronics is very important subject, very interesting subject, and very easy to understand. This subject is very important, very interesting, and very easy to understand. Why it is a very important and very interesting and very easy to understand means, to appreciate this course, just I will give two examples. These two examples are taken from websites only. It is very important, very interesting and very easy to understand. Why I am telling like this means, one example is, nowadays and in future, only two technologies will dominate the total world. One is computers and other one is power electronics. That is, I am comparing the power electronics with the computers. You know the importance of computers, no? Then that is the importance of power electronics. Okay. The another example is, all the computers and communication systems get their lifeblood from the power electronics only. Okay. That is the importance of power electronics subject. That's why it is very important subject and very interesting subject. Why I am telling it is a very important means, this plays very important role nowadays and in future. Why I am telling that it is a very interesting subject means, because in all the practical applications we are using this subject, and I am comparing this power electronics with the computer. That's why it is a very interesting and very easy to understand. Why I am telling that this subject is very easy to understand means, except power semiconductor devices, starting from rectifiers ending up to cycloconverters, all these are the power electronic circuits. To analyze any power electronic circuit, it may be rectifier or chopper or inverter or AC voltage controller or cycloconverter. To analyze any power electronic circuits, we can use KCL, that is Kirchhoff's current law, KVL, that is Kirchhoff's voltage law, and we can use what the response of RL circuit, RLC circuit, RLE circuit with DC and AC excitation. All these fundamentals you can use In order to analyze any power electronic circuits, all these fundamentals we are studied in the lower classes. That's why by using these fundamentals, we are analyzing the power electronic circuit. That's the reason why the power electronics is very easy to understand. Understood? Yeah. That's why I'm telling that it is a very interesting subject, very important subject, very interesting subject, very easy to understand. Understood? Yes. Now tell. Here I am telling that power electronics is the more popular technology. How to say that power electronics is the more popular technology as compared to any other technologies? We are telling that power electronics is the more popular technology. Why you are telling that power electronics is more popular technology? If any technology is more popular, it must satisfy following factors. If any technology is more popular means it must be a efficient technology. If technology is more popular means it must be efficient technology. Yes. And it must be less size. And it must be less weight. And it must be less cost. And it must be more reliable. If any technologies satisfy all these factors, then we can say that the technology is more popular technology. Power electronics is satisfying all these factors. That's why I am telling that power electronics is the more popular technology. Sir, how to say that power electronics satisfying all these factors? Yes, it is very simple to explain this. We know that all the power semiconductor devices used as a switches in power electronic circuits. Yes, sir. You take rectifier or chopper or inverter or AC voltage controller or cycloconverter. In all these circuits, we are using some power semiconductor devices. It may be diode or BJT, MOSFET, IGBT, GTO. All these power semiconductor devices used as a switches in power electronic circuits. For example, what do you mean by operation of chopper? Switch on, switch off. On off is nothing but a switch concept. Yes, sir. What is the operation of rectifier? What is the operation of rectifier? Yes. Thyristor on, thyristor off. Positive off cycle, negative off cycle. On and off only we are doing. On and off is nothing but a switch concept. Yes, sir. All the power semiconductor devices used as switches in power electronic circuits. That's the reason why power electronic circuits are more efficient circuits. Sir, how to say that? Because of switch, it is a more efficient. Simple. Ideally, I am telling. No doubt at all. Practically, there must be some minimum losses. But first, I am explaining this concept for ideally. Then we can apply for practically. Ideally, infinity means practically high. You take like that. Ideally, 0 means practically less. Okay. Tell me, ideally, if the switch is closed, switch on means switch closed. If the switch is closed means ideally, what is the voltage across the switch? What is the voltage across the switch? Yes, 0. Because it is short circuit now. Once the switch is closed, ideally the voltage across the switch is 0. But practically there is some forward voltage drop. Yes, sir. But ideally I am telling, voltage across the switch is 0. But it carries any current now. But it carries any current. Yes, sir. That's the reason why. Current is exists but voltage is 0. Then what is the power loss? 0. If the switch is open, what is the current through the switch? 0. But ideally there is some leakage current in any semiconductor device. Sorry. Practically there is some leakage current. Sorry, I am telling that practically. Practically there is some leakage current. But ideally leakage current is 0. That's why it blocks the voltage. but current is 0. Voltage is exist, current is 0. Power loss is nothing but voltage into current. But switch is open condition, voltage is present, but current is 0. Then what is the power loss? 0. If the power loss is 0, then efficiency high or less? Then high efficiency. That's the reason why power electronic circuits are more efficient circuit, because all the power semiconductor devices used as a switches in power electronic circuits. Very important statement. Why the power electronic circuits are more efficient circuits? Because all the power semiconductor devices used as a switches in power electronic circuits. Switch means it is operated in cutoff or saturation region. Saturation region means closed switch. Cutoff region means open switch. Understood? More efficient means less power loss. Less power loss means high temperature rise or less temperature rise. Power loss is less means less temperature rise. If the temperature rise is less means, then what is the cooling requirement? More cooling requirement or less cooling requirement? Yes, less cooling requirements. Okay. If the cooling requirements is less means, then what is the size? Less size. That's why it is satisfied. If the size is less means, what is the weight? Yes, less weight. It is also satisfied. Because of less temperature rises, are more efficient, then the device is more reliable. Means it works for a long time. Yes sir, it works for long. That's why it is more reliable. Then what is the cost? No doubt at all. In the cost point of view, the initial cost of the power electronic circuit is high. But if you take some payback period, either 6 months or 1 year payback period, the cost of the power electronic circuit is also less. Take one simple example. Nowadays we are using one fan regulator. No? Yes sir, we are using one fan regulator. That is a power electronic circuit. That is a triac based circuit. That is a triac based AC voltage controller. Yes sir. For fan regulator, the input to the regulator is AC. The output of the regulator is also AC. That output is given to the ceiling fan. Then by controlling this regulator, we can control the speed of the fan. Then that fan regulator acts as one AC voltage controller. That is one of the power electronic circuit. See the size of that regulator. That nowadays whatever the fan regulator we are using. Okay, very small regulator. See the size, very less size. Weight, very less weight. We can operate that regulator for 24 hours. We can touch that regulator. The heat dissipation is negligible. Understood? Okay. But in the olden days, we are using fan regulator that is very large in size. Very large in size. Just after operating 1 or 2 hours, then we can touch that regulator. There is a large heat dissipation. And during operation also we can get tick tick sound. Understood? Smooth operation also not possible. You compare this power electronic regulator and conventional regulator. Power electronic regulator and conventional regulator. Just for example I am telling that. It is not exact cost. This example I am telling. Let us assume that the initial cost of the power electronic regulator is 70 rupees. But the initial cost of the conventional regulator may be 50 rupees. The initial cost of the power electronic circuits are high. But we are using this regulator for 1 year. And this conventional regulator is also used 1 year. After 1 year, because of power electronic regulator, power loss is less. Yes? Power loss is less means high electricity bill or less electricity bill? Less electricity bill. Then because of power electronic regulator, for 1 year, I paid only 50 rupees. Then after 1 year, what the cost of the power electronic regulator? 70 plus 50, 120 rupees. Then conventional regulator, because of large power loss, high electricity bill. Then after 1 year, for 1 year usage of conventional regulator, I paid 100 rupees electricity bill. After 1 year, what the cost of the conventional regulator? 150 rupees. See the cost also. That's why power electronic regulator is less cost as compared to conventional regulator if you consider some payback period. Yes, the initial cost may be high. But if you consider some payback period, the cost is also less. This is also satisfied. All these factors are satisfied by power electronics. That's the reason why power electronics is the more popular technology. Among all the technologies, which is the more popular technology? Power electronics is the more popular technology because of these reasons. Then, what is the exact definition of power electronics means? Power electronics is the technology associated with efficient conversion and control of electrical power by using power semiconductor devices. Understood? That is the exact definition of power electronics. Then note down what is the power electronics? Yes. Power electronics is the technology associated with efficient conversion and control of electrical power by using power semiconductor devices. Efficient conversion and control of electrical power by using power semiconductor devices. Yes. The another point to remember, power electronic circuits are more efficient because all the power semiconductor devices used as a switches in power electronic circuits. Okay, note on this. Power electronic circuits are more efficient. Because all the power semiconductor devices used as a switches. Okay. In bracket you write saturation or cutoff region. Okay. This is some introduction to the power electronic subject. That is the importance of power electronics. Then what is the definition of power electronics? What is the definition of power electronics? Okay. Now with this knowledge, now we go for according to different chapters what I given at the topics. Okay. The first chapter is in power electronics. I will start with the types of switches. I given the statement now. All the power semiconductor devices used as a switches in power electronics. Now we'll see the concept of switch. What are the different types of switches we are using? In power electronics? Now we'll start with the types of switches. In the types of switches, I want to discuss so many topics. Okay. That for any competitive point of view, the topics are started from types of switches only. From this, every point is important for any competitive point. Every point, whatever the points I am dictating or whatever the points I am explaining, every point is important. The first chapter is, I will start with the types of switches.